Okay, we're going to start. We're going to do limits and derivatives today. Let me give it 1 second. Okay. Person should be here, so I think we can get started. Hopefully everybody can see everything. It's a little bit delayed, I think, but I think it'll be fine. Okay, I'm going to get started. Okay, so we're going to do limits and derivatives. When we do the limits, we're going to do heaviness, we're going to do L'Hopital, we're going to do definition derivative. And when we're doing derivatives, we're going to do regular derivatives, implicit differentiation, and logarithmic differentiation. So we're going to start off with limits because that's the logical thing to start off with. So I'm going to write a couple, maybe 3 limits or so. Maybe I'll wait a minute and let you try them for yourself. So these are the limits I have in mind right now. 1 over x minus 1 over 5, x minus 5. So we're going to do that one. Then we're going to do limit as x goes to, let's say, negative infinity, x to the 4th minus 3x squared over x squared plus 4x plus 1. And then we're going to do what? What else do we want to do? Let's do some trig stuff because a lot of times students struggle with trig. So we'll do inverse sine 4x over sine of 3x. So as we do these first 3 questions, I'll be able to think about what we will do for the next few questions. Okay, so these are our first 3 questions. I'm going to get started with these first 3 questions. Just keep in mind that, again, there's 3 ways to do limits. Maybe we should have started off with that, actually. So I'm going to write that real quick before we do these questions. So the 3 ways to do limits, the first one is heaviness. So limits, heaviness. And when you have heaviness, there's 3 types of heavinesses. There's same heavy, there's top heavy, and there's bottom heavy, of course. So same, bottom, and top. Same as the ratio. Bottom is 0 will be the answer, and top will be plus or minus infinity. We have to determine between plus or minus infinity. Then there's definition of derivative. That's my favorite way to do limits if it's of the right form. Unfortunately, you can't do it for every single question, but let me quickly write down what that will be. This is the one that people say is not contained in H, obviously, because it doesn't contain an H. And then this one is the one that does contain an H. So f of a plus h minus f of a over h. So there's that. And then finally, there's L'Hopital, which is the most ubiquitous way to do limits. And that's if you test if it's 0 over 0 or infinity. Usually it's 0 over 0. You just take the derivatives. So hopefully everybody can see that. So this is f of g over g, and then we take derivatives. A lot of people wonder what method should I use for each one. And here is sort of the guidelines. So for heaviness, you do it when you're going to infinity or negative infinity. For definition of derivative, you have to do it of these 2 forms. So keep in mind, like, for example, if there's an x squared on the bottom, or sine or cosine e to the x ln, something like that, you would not be able to do definition derivative. And then L'Hopital, again, is the most ubiquitous one, so it's whenever you get 0 over 0. But I'm going to try, now that we know our methods, we're going to try to do these limits. So in this first one, notice is of the form definition derivative, so you can do definition derivative. Just keep in mind that for any other definition of derivative question, you can also do L'Hopitals. I'm going to do both ways just for your benefit real quick. So I'm going to do definition derivative first because that is the spirit of the question. So I'm going to identify the function. What is the function here? Well, when you do definition derivative and you have the not h form, which is this form right here, when you have x minus a on the bottom, the function is easy to identify because it's in the top left corner of the numerator, so it's 1 over x. A is also easy to identify because there's literally an arrow pointing to it, so it's going to be 5. Then you take the derivative. Remember that if you're doing definition derivative, you can just forget about the limit once you identify these 2 things. So I'm going to take a derivative. If you're new to derivatives, you might want to write this as x to the negative 1. in order to use the power rule, because I don't want to use quotient rule here because there's an x on the bottom and a constant on the top. If there were two x's, I would be doing quotient rule, but here it's easier to do power rule. And how does power rule work? Well, you drop the power down, so it's negative x to the minus 2, because then you subtract 1 from the exponent. Now that we've taken a derivative, to finish the question, all you do is you plug in 5. And then the hardest part maybe is actually the algebra. So I'm going to simplify this. This is 5 squared, so the answer is negative 1 over 25, because 5 to the negative 2 means, the negative portion means that you take it to the denominator. So that's the answer. I like definition derivative, but again, I'm going to do L'Hopital because a lot of people like to L'Hopital everything. Let's first check to see if you get 0 over 0, and you do, because you get 1/5 minus 1/5 over 5 minus 5, so that's 0, 0. If you want, again, you can write it as x to the negative 1 to do power rule. So here we're going to do L'Hopital on the bottom here. Obviously, if you're taking a test or something, you don't have to do both ways, but you can use both ways to check yourself. X to the negative 1 will be negative x to the minus 2. It's derivative. We just did it before. The derivative of negative 1/5, of course, is 0. And then the derivative of x is 1. When you do L'Hopital, remember that any limit should have no x's in the answer, because you still have to plug in the answer, plug in the number. I'm going to plug in 5, and I'm going to get the same thing, negative 5 to the negative 2, which is negative 1 over 25. So that's a pretty classic example of a definition derivative question, which you can also L'Hopital. Let's move on to this middle one. This middle one is going to negative infinity. We have a polynomial over a polynomial. So it looks like we should be doing heaviness. This is the prime time to do heaviness. So it's going to be x to the 4th over x squared. So let's first compare. Well, we have a 4 here and we have a 2 here. So that means that this limit is going to be top heavy. So this is top heavy. And then whenever you're doing top heavy, remember what you want to recognize is whether the answer is infinity or negative infinity. So I'm going to write infinity, and it could be plus and it could be minus. Are any of these people taking pre-calculus right now, or is everybody taking calculus? Okay, I don't care. So we have this limit, and we have to determine whether we want positive infinity or negative infinity. So in this question, we're going to take negative infinity, and remember what you do is you plug it into the biggest exponent of the numerator and the biggest exponent of the denominator, just like you do any same heavy, top heavy, bottom heavy. So if you want, you can ignore all of this. Again, top heavy is the trickiest one because you have to determine whether you want positive or negative infinity. So to do so, what we're going to do is we're going to take negative infinity and plug it into the top one, and that'll be negative infinity to the 4th. That's positive. And then the bottom one, it's going to be also positive. So this one, even if we're going to negative infinity, this answer will be positive infinity. Again, it's a pretty hard, this is actually the hardest heaviness question, where in same heavy and in bottom heavy, you just know the answer right off the bat. And in top heavy, you do have to determine whether you want infinity or negative infinity. Okay, let's move on to this third question here, now that we've done with that heaviness question. So yeah, bottom heavy is the easiest question, which is why bottom heavy doesn't appear a lot on tests. But this one would appear. This is going to be L'Hopital. If you don't know if something is 0 over 0 and you want to get credit for work, you should probably just assume it's 0 over 0. Sine of 0 is 0, which means inverse sine of 0 is also 0. So this is pure L'Hopital. I know it's L'Hopital because it has trig in it. Let's take the derivative together. Also, one thing is that as you're taking these derivatives, a lot of times students miss little chain rules, so just be careful. There's a lot of little chain rules all throughout. So for example, let's take the derivative of the denominator first because it's easier. Derivative sine of 3x is going to be cosine of 3x. But again, because of that 3 here, you do have to do the chain rule, so it's going to be times 3. Yeah, I bet you'll be fine with these derivatives. But the inverse sine derivative will be slightly harder, so just be wary of that. I'm going to write down the memorized form in the top here. 1 over square root of 1 minus x squared. And then I'm going to plug in this derivative. So there's two things that people mess up when they're plugging in this derivative. So this is a practice of the chain rule if you want some practice with the chain rule. So this is the outside derivative, and we're going to take this x and we're going to plug in 4x. So it's going to be 1 over the square root of 1 minus 4x squared. And notice that I'm being careful with these parentheses because 4x should be being squared because the inside is x squared. But I do have to multiply by 4. And why do I have to do that? It's because of the chain rule. So anytime you have this 4x, 3x, negative x, 5x, 8x, 1/2 x, you're always multiplying by the derivative of the outside at the end. Now that we've completed with the derivative though, now it's the easy part where we have to plug in the number, and here the number is 0. You don't have to do the quotient rule. A lot of people confuse quotient rule and L'Hopital, but L'Hopital is for limits and quotient rule is for taking derivatives, if that makes sense. So I'm going to plug in 0. If you plug in 0 here, you get 1 over the square root of 1 minus 0. So here the parentheses actually didn't matter because it ended up being 0, but we should still be careful. On the bottom here, we get cosine of 0, and it's nice to know unit circle, at least the very basic unit circle. Cosine of 0, if you don't know, is 1. So this final answer is going to be 4 because this entire numerator is going to simplify to 4 because the square root of 1 minus 0 squared is 1. Finally, again, cosine of 0 is 1. So this final answer is 4/3. I would rate, in terms of difficulty out of 10, I would say probably the first question is probably a level of 3. Any top-heavy question I consider to be moderately hard, so I would consider that a 5. And then this last one, because the derivative was quite tricky, I would consider that an 7. Are we good with this? So this is my 3 limits. We're going to, again, keep practicing limits. We'll practice limits probably for like 25 minutes or so, and then we'll switch to derivatives. I'm going to move on with some more limits. So this is, again, how we're going to do limits. Let's see. I had some in mind that I wanted to talk about. Let's do some harder ones. So let's do limit as h goes to 0 of 1 over e to the 2 plus h minus 1 over e squared h. So that one looks kind of hard. What else do I want to do? There was other ones I wanted to do. Yes, limit as x goes to infinity of ln of 2x plus 1 minus ln of 3x minus 5. And then my other one I want to do, okay, so that's that one, that's that one. Let's do ones with a's, because sometimes when there's constants and stuff, people get confused. So we're going to do this, and it's going to have an a in it. So it's going to be a to the x minus 1 over, let's say, 3x. Okay, see, these are our next 3 questions. I'm just going to proceed because I'm too excited to, I don't really want to wait, to be honest. So let's do these 3 limits. I'm going to take them each one limit at a time. Let's take this limit first. So anytime you have an h limit, the pure way to do this question is definition derivative because you have this h thing. When I do this, though, I'm going to do it 2 ways. I'm going to do L'Hopital because some people like to L'Hopital everything. So let's get started. When you have doing definition derivative, you want to identify 2 things, the function and the number. I actually like to identify the number first when I do these questions. With the h's, because it's easier to identify, in my opinion. What you do is you look for the number that's getting added to the h, and notice that 2 is getting added to the h, so a is equal to 2. Now I have to identify the function. That one is a little bit harder to identify, especially compared to the not h one, because it's not just in the question. What you do is you take the number plus h, because in this formula you have f of a plus h. You take the number plus h and you cover over it and cover it up with an x, if that makes sense. And then you read off the function. So if I replace this 2 plus h with an x, notice the function will be 1 over e to the x. So now that we've identified these 2 things, remember we are ready to take the derivative and we're ready to plug in the number. We can really just forget about the limit. One thing to keep in mind, though, is that this derivative is a little tricky. Again, you can try to avoid the quotient rule because notice that we have 1 over e to the x. And 1 is a constant, so I really don't want to do quotient rule. I'm going to write this as e to the negative x instead, and I'm going to try to do chain rule and avoid quotient rule altogether. So let's take this derivative. Well, the derivative of e to the x is e to the negative x, because the derivative of e to anything is that thing. But just be wary that because we have e to the negative x and this negative, this is where people mess up again. This is the little chain rules. We have to multiply by -1. Then, once I've taken the derivative, notice all I have to do is plug in the number. So it's going to be e to the -2 times -1. You don't really have to simplify this too much because it's an e. So I'm going to leave this answer as negative e to the -2. Hopefully that makes sense. Okay, but again, people like to definition derivative everything, so I'm going to do that. If I were to do definition derivative, it is useful, again, not to write this as a quotient, but instead write this as something like e to the negative 2 plus h. Using a negative exponent will allow me to avoid the quotient rule, and instead I can do the chain rule instead. So let's start this. Limit as h goes to 0. So I'm doing L'Hopital, by the way, because some people like to L'Hopital everything. Bottom should just be 1 because the derivative of h is just 1. And then finally, we're taking the derivative of this function right here. Again, let's be careful with the chain rule. It's going to be e to anything. So it's going to be e to that thing, because that's how e's work. But then we have to multiply by the derivative of the inside. And because the exponent is the inside, notice the derivative here will be negative 1. So we're going to have to multiply by negative 1. Notice whenever if you're very careful and you like to do a question in two different ways so you can verify your answer, notice your derivative will be very similar, e to negative something times a negative 1. If you're doing L'Hopital and definition of derivative to check your work. The thing that people mess up is the derivative of negative 1 over e squared. They want to take that derivative just like how we did, write it as a negative exponent, take the derivative. But notice that this has no variables, which means that this is a constant, so the derivative of this entire quantity is 0. So we're actually done with the derivative, and we're going to plug in 0. And notice we get the same thing, because we're going to plug in 0 for h. We get e to the negative 2 times negative 1. That's the same thing as this. So that's actually a pretty tricky question, especially the rewrite. You could have gotten the question right if you did quotient rule, but it's just a harder derivative. If you're doing quotient rule, it's harder to simplify and so on. So just recognize that if you have a number over something, you really don't want to use quotient rule. You probably want to use a negative exponent and chain rule. Okay, so this middle question is a little bit of the rare variety. We are going to infinity, so that means that we can do same heavy and top heavy and bottom heavy. But first off, there's a very famous log property from Algebra 2, or you're studying for your SAT or ACT days, where you can sort of simplify these ln's. And this is how I'm going to do it. The rule is that ln of A minus ln of B is equal to ln of A over B. ln, so I'm going to write this as these two ln's. So it's a division of ln as opposed to a subtraction of two separate ln's. And then, because ln is continuous, we're allowed to take the limit inside. So we're going to take the limit inside. And if I cover this up, notice that the inside is very simple because it's just same heavy, 2 over 3, because this is x and x. So in this inside, we're going to get same heavy. So the answer is 2/3. But again, some students think the answer is 2/3, but remember, we still have this ln. So I'm going to write ln of 2/3, and that's the final answer. So just be careful of that. A lot of students think the answer is 2/3 and they forget the ln. And while I like my students to simplify as much as possible, for both of these past answers, because we have e's, because we have ln's, you really can't simplify that. So we have to leave our answer like this. Okay, this question right here. This question, people want to do definition derivative because it kind of looks like definition derivative. It has the x on the bottom. It has going to a number. But again, you only can do definition derivative when it's x minus the number. So this 3 is preventing it from being definition derivative. So we unfortunately just can't do definition derivative. We have to do L'Hopital. We're going to plug in 0. And a lot of students struggle with this a here. Just keep in mind that a is a constant, so the answer will contain a in it. We can just proceed as normal. What's a to the 0? Well, we don't know what a is, so I'm a little bit panicking right now, but don't you worry, because a is a constant. No, not the fact that a is a constant, but the exponent is 0. So a to the 0 will be 1, because anything to the 0 is 1. So 1 minus 1 is 0. And then I'm plugging 0, and I get 3 times 0, and that is also 0. So it looks like we have a L'Hopitalable candidate for a limit. So I'm going to start taking derivatives. Remember, I'm not confusing this for the quotient rule. I'm doing the derivative of the top and the derivative of the bottom independently of each other. I'm going to take the derivative of the bottom to build my confidence. The derivative of 3x is just 3. Now I want to take the derivative of the top. Just be wary that I'm not going to do power rule here, because x is the exponent as opposed to the normal x being the base and the number being the exponent. A preview for stuff we're going to do later is when x is in the base and the exponent. That's going to be log diff. But for right now, we have a number, which is a, as the base and x is the exponent. And this is the a to the x rule, and it's literally called the a to the x rule. So we should be able to take its derivative pretty easily as a memorization. What's the derivative of a to the x? Well, that's going to be a to the x times ln a. Now what we're going to do is, remember, for the final step is that we can't have x's in the final answer, so we still need to plug in 0. So we're going to plug in 0, so it's going to be a to the 0 times ln a over 3. Again, let's not panic that we don't know what a is, because a to the 0 is going to be 1, because again, anything to the 0 is 1. So our final answer here is ln of a over 3. Just like the previous ones, because we have an ln and we don't really know what a is, we can leave our answer like this, as opposed to if we had like a square root of a number we knew, or like a trig value of pi over 3 or something where we would have to simplify. Here we can be just done with the question. Okay, so those are my limits. I don't know if we want to keep doing limits. We could maybe do a couple more, or we can try to do some backward stuff and writing L'Hopital in the precise way. It's about 21 minutes, so it makes sense maybe to go on to the other ones. Yeah, I'm going to do MDiff after we do the 2 middle questions, if that makes sense. So let's do the 2 middle questions pretty quickly. Let's do the middle questions. So basically it's going backwards. So we're going to write f prime of 3 as 2 different limits. 2 different limits. But of course, we need a function. So let's not go too crazy. Let's have multiple x's just to make it slightly crazy. So it's x squared plus 2x minus 1. And then we are going to write this as 2 different limits. So basically, we're going backwards. Instead of identifying that a limit is definition derivative and then doing definition derivative, we are going to try to write the limit as a definition derivative. So let's do that. So the forms are right here if you want. This is the not h1 and this is the h1. I always like to prefer to do the not h1 because I think that's easier to do. So it goes limit as x goes to a. So in this case, it'll be limit as x goes to the x value, which is 3. And then it'll be the function minus f of a over x minus a. So let's do the denominator first, actually, because it'll be x minus 3, x minus whatever this number is. Then you have the function. So the function is right here, and notice it's in the top left corner of the numerator. So it's going to be x squared plus 2x minus 1. And then finally, we have to subtract off the function value. So I should have done this a little bit earlier maybe, but I'm going to take my 3, I'm going to plug it in my function. Here's where math comes to fight me, but let's plug in 3. 3 squared plus 2 times 3 minus 1, what is that? Okay, this is kind of embarrassing, so I'm going to write it on the side. 3 squared is 9, 2 times 3 is 6, minus 1. 9 plus 16 is 15, so it looks like we have 14 as the point. So it'll be minus 14. And we're actually done with our answer. Again, the limit is the answer. Now I'm going to do it the h way. Anytime you have the h way always starts off with this, where h is on the bottom. Just like with the not h way, it'll be minus the number. So it looks like it's going to be minus 14. Hopefully people are checking my work as well, because sometimes I'm not good at math. But I think it is 14. And then to finish this off, it's the top left of the numerator. And the top left of the numerator is f of a plus h. So I'm going to take my number, 3. I'm going to add h. And then anytime I have an x, I'm going to replace that with 3 plus h. So it'll be 3 plus h squared plus 2 times 3 plus h. And I still have to finish the function, so I'm going to squeeze in a minus 1 here. And that is the answer to writing this function's derivative at 3 as 2 different limits, one with an h, one without an h. Hopefully that makes sense. Okay, so I'm going to now do the L'Hopital thing. So it's going to be, let's do a very simple question. We can have e's in it, why not? So we'll write this, and then we'll have 4x. Okay. So on the College Board, if you're taking the AP exam, for free response questions, you have to write L'Hopital in a very precise way, and this is how you like to write it. Basically, they don't like if you write it 0 over 0, so you have to write it in this format. You write the limit of the top equals 0. And if you don't know, again, e to the 0 is 1, because anything to the 0 is 1, so this is 0. Then you have to write the limit of the bottom equals 0. Let me write, my brain's not working right now, so this is also 0. 4 times 0 is 0, of course. And then you write by L'Hopital's rule. and you write the new limit, old limit, sorry, and you set it equal to the derivatives finally. Here, there was no chain rule shenanigans or product rule or quotient rule, just this pure derivative. Derivative of e to the x is e to the x, derivative of minus 1 is 0, the derivative of 4x is 4. Plugging in the number at the end, e to the 0 is still 1, so the answer is 1/4. But just be wary of this format of the AP exam for L'Hopital's rule, where you have to write the limit of the top equals 0, limit of the bottom equals 0 by L'Hopital's rule, and then you write this limit of the original, and then you take derivatives next. Okay. So some people wanted to do MDiff, so let's move on to MDiff. So this is really derivative side. We're going to do some MDiff questions. We're going to do log diff questions. We're going to do also regular derivative questions. Let's try to do it all. So I'm going to write 3 derivatives. Let's skip the easy ones, to be honest. Let's go straight to ones that have product rule, because a lot of them do have product rule. So we're going to do this. We're going to do 4xy. We're going to do cosine of y, and then we're going to set this. There shouldn't be 2 equal signs, so this is a badly written plus, and then this will be 7. So that'll be my first question. Second question will be just, let's see, what should we do? Yeah, just some fun derivative stuff. So we'll do, we always do like 3x or 4x, so let's not do that. Let's do tan x or something. Okay, and then let's just add 5 for fun. And then this last one we're going to do, might as well write 3 questions. Again, let's take it up a notch in terms of the difficulty. So let's do like, I don't know, sine of 2x to the ln x. Okay. So these are my 3 questions. So really, if you want, you can think of every single question as being MDiff. Like even this middle question, when it doesn't have any y's on one side and it's just y, when I take the derivative, it will be y prime, because the derivative of y is always y prime, and you can just start taking derivatives. This is fine in regular y prime, yeah, not y double prime. Y double prime is way harder, and it comes up later. But as that person is saying, just keep in mind that anytime you have a derivative of y, you do need y prime. So this is y prime, this is y prime, this is y prime. Let's get started with this one on the left. That one looks like the hardest. So I'm just going to start taking derivatives. The thing you definitely don't want to do, and I think students eventually learn to do this, is you don't want to solve for y because it's impossible. Yeah, for related rates, basically there's t's in the question, so you will have x primes when there's t's in the question. But for now, we're just doing a pure derivative, so let's get started. Derivative of x cubed is 3x squared. And then we have to do product rule here. This is a very common construction in MDiff questions when you have a number times x times y. And remember, what I like to do is I like to attach the -4 to the x as I do the product rule. And so my second thing is y. Now I'm going to take the derivative with product rule. So it's going to be keep the same. Then the derivative of y. But again, the derivative of y is not just 1, it's y prime. So it's y prime minus or plus the derivative of -4x, which is -4. And then we can just keep that the same. So notice I don't have any x primes here. Again, x primes are for related rates, but people might not know that. So I'm done with the product rule, it looks like. So now I'm going to go to this right side. The derivative of cosine y, just be careful with the derivatives. Anything that starts with a c and it's a trig function starts with a negative. So the derivative of cosine is negative sine y. But just be careful. Anytime you have a y, you need y prime. So this is going to be times y prime. Okay. So once you do that, you want to bring all the y primes to one side, all the not y primes to another side. These 2 terms are the terms that have y primes, so they should go together. Because this one's already over here, I'm just going to bring over this first one. So it's going to be 3x squared, because the things that don't have the y primes will stay on this side. And it'll be negative sine of y times y prime. And I'm going to bring over this -4x y prime through addition, of course. So that's that. Then I'm going to now divide. If you want, you can do this in 2 steps. Take out a y prime and then divide. But once you do enough of these questions, you should see what you divide by. It's just anything that y prime is multiplying by. So it's going to be negative sine y, and it's going to be plus 4x. And that's the answer. Keep in mind that MDiff questions are usually fractions because you end up dividing by something with y primes. And you are done when you don't have any y primes on one side. So notice that we only have x's and y's. And that's how you do these questions. Take the derivative, potentially being careful with product rule. Secondly, anything that has y's, you need y prime. and then you factor out. Okay, we're going to move on to this question right here. So this question right here looks like it's a pure derivative. There's no y's on this side. There's not even anything besides the y on the left side. So it's just a derivative, but it's still nice to practice derivatives. So just keep in mind that sometimes they just add plus 5. Yeah, so when I do limits, I do either heaviness when it's going to infinity or L'Hopital. And then when I'm doing derivatives, do not do L'Hopital because you can't do L'Hopital for derivatives. So I just identify what question it is, imp diff, log diff, and so on. There are some questions that make definition derivative easier, but it's sort of a choice that you have. Do you want to do easier questions or do you want to do the same thing every single time? And it's not that much more difficult when you're doing limits, for example. Okay, but we're going to take this derivative. The derivative of plus 5 is 0 at the end, so really we can ignore that. This is the most uncommon derivative, probably, inverse secant. So let's remind us what that is. It's going to be x over 1 over x times the square root of x squared minus 1 as the memorized derivative. Always good to memorize your derivatives because you don't want to miss points just for memorization. Okay, so now we're going to take the derivative. Keep in mind, here's the inside function. So we're doing the chain rule if you don't know. We start off with our 3, and then we're going to take our tan x and we're going to plug it into our function. So it's going to be 1 over tan x square root of tan x and squared minus 1. So anytime I have an x, I replace it with my inside function. That's only half of the chain rule. You have to finish the chain rule by multiplying by the derivative of the inside. And what's the derivative of tan x? That's secant squared. So that's that answer. Cool. Unfortunately, I don't have enough space for this question, so I'm going to do it on the bottom here. So this is pure log diff. To be honest, I don't really know why I asked log diff anymore because I don't think it's appeared on the AP exam since like the 60s or something. But it's not the hardest process in the world, and it does appear on college exams, so I still teach it. It's one of the only topics that I teach that likely would not be on the AP exam, but we can still do it. And why do I know it's log diff? Again, it's because it has x's in the base and the exponent as opposed to x in the base, a number in the exponent, which is power rule, or a number in the base and x in the exponent, which is the a to the x rule. So just remember that log diff is called log diff because you want to take logs. So you take the ln of both sides. So I'm taking the ln of both sides. And the reason why we do this is another log property that if you have ln of a to the b, you can drop the b to the front. So we are going to do that right now. We're going to take this ln and drop it to the front. So notice that I haven't taken a derivative yet. This is just using some sort of algebra 2 or pre-calc rule with logs. And next step, I'm going to take a derivative. So now I'm going to take my derivative. Just keep in mind that the derivative of ln of y is y prime over y. That's imp diff. It's 1 over y times y prime. Just be wary that it's always y prime over y. And then this side, you're always going to do product rule because you drop the power. So it'll be whatever you had times the base. So the old power times the base, you'll always have product rule. Let's start product rule. Let me actually be a little careful here because this derivative might be kind of long. So ln of x, that derivative is 1 over x. So let's start off with that one. So that means we're going to keep the other one the same. Again, I'm doing product rule here. So sine of 2x. And then I'm going to do the second half of the product rule. So is derivative keep the same? Now I'm going to keep the same of ln x because I took its derivative the first time. Now I have to take this derivative, which looks a little hard, but it's not too bad actually. 1 over, anytime you have an ln, it's 1 over the thing. So it's 1 over sine of 2x. And again, just keep in mind that all these things have chain rule. So what's the derivative of sine of 2x? That's negative cosine of 2x. Let me see if I can squeeze that in. And then because there's still this 2x, I still have to multiply by 2. So now we're writing really, really small. Maybe I should just rewrite it on the bottom here. So I multiply by negative cosine of 2x times 2. Don't judge me, people. I'm trying my best. But here we had a double chain rule. We had 1 over the inside. Then we took the derivative. Isn't it positive cosine? Yeah, I'm not good at math. So again, don't judge me. I'm just trying to test you. The derivative of sine is positive cosine. So this would be a positive cosine. Good work, I guess. So, but I was doing chain rule. So it's 1 over the thing. Everybody should know that the derivative of trig functions that don't have a c are positive, so this is obviously cosine. No one would ever make the mistake that this was negative. And then you still have to do the chain rule of times 2. We're not done though. We have to bring over the y. Usually people do this in one step, but if you're doing it for the first time or so, you might not want to. If we were doing simplifying, cosine over sine is cotan, so just be wary. If you're taking like a exam, maybe like a college exam or something, they might simplify these derivatives, but we're not going to simplify because that's not really the game we're playing right now. So basically, to finish off the question, you bring over the y, and y is this. So we're going to replace y with this. I'm going to write this down. So we have this, we have this, and then you just recopy this parentheses, or you just did it in the previous step. But let's do it a little bit small so I can squeeze everything in. So that's that, plus ln x times 1. So I'm just copying again. And the harder part was the second derivative because it was a double chain rule. 1 over something times cosine of the thing times the inside, which is 2x. The derivative of 2x being 2. Hopefully that makes sense. That's a pretty difficult log diff question because you have all this chaining and stuff. Obviously, I just missed it, but that's the process as you do this. So why don't we finish off by doing 3 more questions? So let's do 3 more questions. Hopefully nobody has any questions on that. Okay. So 3 more questions. First question, let's see. What do I think people don't know? Something like this maybe, like y is equal to 8 to the sine squared x times, okay, I don't know what I'm doing right now. Let's do cosine of 3 over x for one of my friends who struggles, sometimes doesn't know how to do the 3 over x part. Then we're going to do harder questions. Let's do a harder question. So we're going to do my favorite sine of xy. I like asking this question so much. Plus y cubed equals 3x plus 2 or something. And then we'll do another question that was similar. Let's do x to the 4th is going to be my exponent. I know that. And let's do tan. Okay. So let's start off with these questions. Because we've sort of discussed things, I'm going to just go straight to the question. So this first one is a pure derivative. It doesn't have any x's in it. So what we're going to do is we're going to rewrite it so that it will be easier to take the derivative. Anytime I have sine squared, remember I like to write it as sine of x squared. This just makes the derivative easier, and it makes it more obvious what is the chain rule, what's the inside when you're doing the chain rule. And then I'm going to rewrite 3 over x as 3 times x to the negative 1. Again, it'll be easier to take the derivative in this way because I'll be able to employ power rule more easily. So this is going to be a nasty derivative, but once you do enough derivatives, really no derivatives are any harder than any other derivatives if you know the rules well. It's going to be a product rule. Let's take this derivative. Keep in mind that this is not going to be power rule for this because we have 8 in the base. This is the a to the x rule. So it's a to the 8 to the whatever this is. And then I have to multiply by the derivative of the inside. What is the inside? Well, it's going to be this exponent here. So it's going to be 2 sine x. And unfortunately, I still have a little bit of an inside because this is a triple function. So I have to multiply by the derivative of the sine part, which somebody corrected me earlier, is cosine. So this is just the first derivative. Then I have to multiply by keeping the same. So I'm going to keep that the same. And then finally, I'm going to multiply by the derivative. I'm going to do the second half of the product rule. So I'm going to do it underneath here because I ran out of space. I'm going to keep this the same. And then I'm going to multiply by the derivative of this one. Well, this one has a cosine, so and a c, so the derivative of cosine is negative sine. I'm doing chain rule, of course, so I'm going to keep the inside the same. And then I have to multiply by the derivative of the inside. Well, that's going to be power rule. That's the reason why we wrote it with a negative exponent, so that we can do power rule instead of quotient rule. So it's going to be negative 3x to the negative 2. And that is going to be my derivative. Okay. This derivative right here, so my board organization or paper organization is not incredible, but let's go for this derivative. So this derivative, I like to always take the derivative of the easiest thing. I don't go in order usually. The derivative of 3x plus 2 is just 3, so let me build my confidence slightly. And the derivative of y cubed is not too bad as well, as long as I remember the y prime, because it has a y prime. Now I'm taking the derivative sine of xy. Again, this construction comes up in the more difficult MDiff questions when you have sine of xy, cosine of xy, e to the xy, tan xy, secant xy, something like that. So what you do is you take the derivative, cosine, the derivative of sine is cosine. We leave the inside the same, which is xy. But unfortunately, because xy is a product, we have to multiply by the product rule as we do the chain rule. And if you take the derivative of xy enough, you'll basically memorize it. But it's going to be x, which is keep it the same, times the derivative of y, which is not 1, but y prime, plus, well, we keep x the same. We kept the x the same, so we have to take its derivative now, so it's 1. And then we are going to keep y the same. So this is the derivative. Hopefully you can see this, even though it's a little bit small. And then this, the step that people struggle with the most is they don't know what to do now because they don't know how to isolate y prime, which is the ultimate goal. But anytime you have this construction of like sine xy, cosine xy, e to the xy, where you have to do the product rule while you do the chain rule, you're going to take this thing and you're just going to distribute inside. You're going to treat it like a number like 5, and you're just going to do 5 times the first thing, 5 times the second thing, but instead of 5, it's this little guy. So I'm going to take cosine xy, I'm going to multiply by the first thing, so it's going to be cosine of xy times xy prime. Then I'm going to distribute this, so it's going to be cosine of xy times y. I probably could have fit it in this space, but what are you going to do? But the reason why we do this again is that it's easier to isolate y prime, because now notice everything is separated by pluses or minuses. So how am I going to bring things to one side? Well, I'm going to use pluses and minuses. So it looks like this should be my y prime side because there's already 2 y primes on this side. So I'm going to just move over this term that doesn't have a y prime to the other side through subtraction. So if you sort of ignore my bad organization, it's going to be cosine of xy times xy prime plus 3y squared times y prime, and I'm going to bring over this guy right here. So it's going to be 3 minus cosine xy. Now all I have to do is I have to do division. I'm going to factor out anything that is multiplying the y prime and then divide by that. So it's going to be this. So sometimes this is hard to write, but the steps are over and over again the same. Take a derivative, maybe be careful with product rule and chain rule, do the y prime stuff. If you have this construction, distribute, but once you do that, y prime's on the left, or y prime's on the left, anything that doesn't have a y prime on the right, divide at the end. And that's the answer to this one. Hopefully that makes sense. I would say that this level is probably like 7 out of 10. This derivative was actually kind of hard too, so that's also a 7 out of 10. This derivative is not too bad if you know how to do log diff, which we're about to do. So this is probably like a 5 out of 10. But let's do it then. So let's write y is equal to tan of x to the 4th. So obviously I don't have enough room here, so I'm going to write it right here. I notice it's log diff because I have x in the base and the exponent. I'm going to take an ln of both sides. Reason why I do this is I can drop the power to the front. That should say tan x. Cool. Now I'm going to start the process. The derivative of ln of y I love because it's just y prime over y. I don't really think about it. And then this is always going to be product rule. Let's take the derivative of x to the 4th first, 4x cubed. That means we keep this one the same. Then we're going to keep this one the same now, x to the 4th. And now we have to multiply by the derivative of ln of tan. Hopefully by now you're getting pretty accustomed to the chain rule, so you know this is chain rule. Outside function is ln, inside function is tan. If the outside function is ln, that means we're going to start with 1 over something. And what is that something? It's going to be whatever was in the ln. So it's going to be 1 over tan to start off with. Then you have to multiply by the derivative of the inside. That's memorized to be secant squared, because the derivative of tan is secant squared. Next, we are going to bring over the y, but I'm going to be lazy, so I'm going to mark out this y. Remember, y is originally this. So I'm going to multiply by y. So like I'm phantom miming of y here because I'm going to replace it with this thing right here. So I would write y, I would erase it, and then I'd put this instead. Maybe some of you are good enough where you can do all the work in your head. Just write one step because it's going to be product rule, which you can kind of do in your head times the original. Even these MTIF questions, if you're like really good with visualization with your math skills, you can do these MTIF questions in your head. But we wrote out 5 steps, obviously. Okay, so these are the derivatives. We might do one more or so. Does anybody have any requests? I was going to do one with quotient rule, MTIF, which is annoying. I don't think we practiced that yet, but all right, yeah, let's do that one. So let's do, what derivatives have we not taken today? Cotan is just like kind of rare, so let's do cotan. And then let's do x to the 5th, I guess. And then the reason why this question is hard is we are going to do e x over y. And then we're going to add 7. Quotient rule is just way worse than product rule, so the e to the x over y is what makes this a little annoying. But I'm going to start off with derivative. Cotan's derivative, if you don't remember, is negative cosecant squared. But because I have a y, I have to multiply by y prime. What's the derivative of x to the 5th? Well, that's 5x to the 4th. Derivative of plus 7 is 0, so I really only have to worry about this term. But this term is going to be quotient rule. It's going to be chain rule first, so it's e to whatever it is. But I look at the inside, and I'm sad because the inside is a quotient, so that's why I have to do quotient rule within chain rule. So when I multiply by the derivative of the inside is a quotient, so I'm going to multiply by a quotient rule. And here, unlike our previous attempts to avoid the quotient rule, we have a variable over a variable, so we really should do quotient rule. So it's low, which is y, times d high, which is 1, minus low d high, minus high, so it's x, times d low, which is not 1, but y prime, of course, over low low, which is y squared. So now we're done with the derivative because, again, the derivative of plus 7 is 0. So we have to isolate y primes here. And this is where you really want to be careful with algebra. I don't like this fraction because it's hard to let this mingle with these two, with this fraction being here. So I'm going to multiply every single thing by y squared. Because what you do to one side of the equation, you have to do the other side of the equation. So when you multiply by y squared to this one, it will be negative cosecant squared y times y squared times y prime, because I'm multiplying this term by y squared. Then I'm going to multiply this term by y squared as well. So it's going to be 5x to the 4th times y squared. And what some students mess up is they'll take this thing and multiply by y squared, but the entire reason we're doing this is that these two y squareds will cancel. And the way math works is that if you have like a fraction x times y over 2 or something, and you're multiplying just by a 2, you don't multiply each term by a 2, you multiply just the entire thing by a 2, so these 2's cancel. So there shouldn't be like a second 2 here. So like when you multiply this by y squared, these y squareds will cancel, so there won't be a y squared here. Some students mess that up, but you would be multiplied by y squared twice, and that's not what we're doing here. And again, the reason why we're doing this is that these y squareds cancel, and you're just left with this. Still being careful with those parentheses. Okay. And then just like before, we can't take y primes to the left and things without a y prime to the right because we have to deal with this term right here. And how do we deal with this term? We're just going to take it and we're going to distribute it inside. Just like anytime you have like e to the xy, anytime you do this sort of chain rule business with either a product rule or quotient rule, when you still have parentheses, your next step will be to distribute once you get rid of that fraction. So this left side doesn't change at all, so let's rewrite that. And then we're distributing this term into this fraction. X, y prime. And now we are good to go. Even if this looks complicated, we have y primes and things that don't have y primes. This has a y prime, this has a y prime, this doesn't have a y prime, this doesn't have a y prime. So then I'm going to do my normal y primes on the left. So this stays on the left. This term is minus, so it looks like we have to add it over. And then we have this term that doesn't have a y prime, so it should stay on the right side. And then finally, we're going to subtract off this term because it also doesn't have a y prime. And then finish off, we're going to get y prime equals this thing right here, minus 5x to the 4th times y squared. And then we're going to divide by anything that the y prime was multiplied by. And that's how you do emptive questions. And this last question, I would rate probably level 10 on the level of difficulty for these particular questions. While derivatives are not as hard as other topics in general, for a derivative question, this is probably a level 10. But hopefully you sort of get used to the process. Anything that has a y needs y primes. Be careful of these really hard ones where you have to do product rule and quotient rule as you do the chain rule. Try your best with simplification, but if you just treat this like a number because it doesn't have a y prime and you distribute it into parentheses, it's easier to separate things. Once you have everything separated, you should be good to go. You take y primes to the left, anything that doesn't have a y prime to the right, and then finally you divide. Does anybody have any questions? I feel like this was a pretty solid review. We did limits, we did impdiff, logdiff, derivatives, we did the limit backwards, we did L'Hopital the precise way, we did definition derivative, same heaviness. I think this was pretty good. We went through about 15, 20 questions or so. Does anybody have any requests before we go? Okay, so this was pretty good. Hopefully this made sense. And we'll be back at it sometime in the future. But thanks for joining.